Hello. Let's get started with the AI car simulation with CoppeliaSim Python part 3. So in this part, we are trying to collect the data set and actually create the data set, and we are going to train the convolutional neural network model for the automatic driving. Okay, so first of all, we need to create like duplicate this part 2, so we have all the code necessary. So we need to go to reveal in file. Okay, reveal in file explorer. Let's copy this, copy paste, and let's make this one the part 3. Okay, let's make the part 3. Okay, after that we will have the let's make this part 3 scene. Okay, part 3, we have part 3 and part 3 scene here. So then we need to start the CoppeliaSim. Here we need to open that file, right? So first of all, we need to find the location where it's situated. Okay, here. Part 3, this one. Okay, we have the maze that we built in the last video. So what we need to do here first is we need to create the dataset, right? So for that, let's go to API and create a new file, dataset collector. Okay, dataset collector.py. Okay. Then I do have a code. I will copy paste it here and explain it to you. Okay, this code also have the same components as in the controller with keys code. So I have like already explained these parts of the code, like connecting with the simulation and getting the handles for left and right models and for the cameras, etc. And like here we are processing the actual video feed that's coming from the camera, flipping, resizing, and converting it into the colors. Actually, what we are doing differently here is like whenever the data comes through, like whenever the video comes through, like we press the W, A, D, and S keys to control the robot. Whenever controlling it, like if I press the W key, I'm saving a screenshot of the actual video feed as an image for in the train data file, forward, left, and right. So this is here what we are doing is we are creating the actual data set. So whenever I press the forward like W key, that means I'm going forward. So I'm creating a image corresponding to it, right? So same as for left, same as for right, right? So here now we need to create these folders, train data, forward, left, right. So here we will create that folder as train data, right? And here we need 3 more folders, left, right, and finally we have the forward. Okay, so simply we are collecting those data into these files, right? So before running this script, we will need to install the dependencies, the CV2 and stuff like that. So here I have created a requirements.txt file. So basically now we are only installing the OpenCV library here. So what you have to type is pip install -r requirements.txt and press enter. So if the OpenCV library is not in your system, it will automatically get installed. So yeah, that's the basic steps to setting up the actual code. Now let's run this code and collect some data from the simulation for training the model. All right. First of all, we need to start the simulation. Yeah, I'm going to start the simulation. Then we need to get the code. It is in the pathway, right? So let's go to cd path 3. Okay. And we have to go to the API and let's run the dataset collector. Python dataset collector.py. Press enter. The program started, connected to remote API server, so it should show us with the video feed. And we can load the simulation also here side by side. Now what we have to do is drive this through. All right. Let's check the folders. Now you can press Q and close this program. Then start the simulation, and we can go to the folder, train data folder, rebuild file explorer. Then if you go to train data, as you can see, we have the data points for forward, left, and right. Okay, so what you have to do is like change the speed here a little bit. Then you can go through the whole track, then collect enough data, right? So after getting collected these data points, now we can continue with the training of the model. All right, the data set is collected. Now let's pre-process the data and create the actual data set. So we will need to create a new folder, model creation. Okay, here let's rebuild it in file explorer, and I have already a script for creating the dataset notebook file. So let's open that one. So what you have here is CV2 is importing the CV2 pickle, and first of all we need to change the location for the dataset. So we know where is it. So we will go back once, train data, that's the location, right? So then we are getting the all the folders after listing them. Then one by one we are like creating the dataset. So let's run this one first. Okay, as you can see, we have forward, left, and right. So for forward we have label 0, 1, and 2. Okay, so forward for 0, left for 1, right for 2. So here what we are doing is we are like dumping the actual labels. So first of all, before dumping it, we need to create the actual folder, data folder. So new folder, data. Then we can run this one. After running, you can see we have actually aicar.pickle file. So then actually, as you can see in the comments, we are like pre-processing the data, like converting into the 50 by 50 image and converting it to grayscale and appending it into the arrays. So let's run this one also. It will take a little bit of time. All right, now we have finished that cell also. So let's run this one, and as you can see for the length of the data set, we have 5478 files, and then before saving the dataset, we need to shuffle it, otherwise the model will get overfitted. So shuffle it. Then we need to append the data, the shuffle data into the actual data and target. Then we need to normalize it, divide the values in from the 255, because these are pixel values. It varies 0 to 255. Then we are reshaping it into a numpy arrays. Then we are like converting the target values also into numpy array, right? Then all right, it's also finished. Now we can run this one and save those data. As you can see here, those data should be saved. Okay, here you go. We have the data. So okay, now let's go to the training part. All right, let's start with the training process. So I have imported the script here. So first of all, we need to import the data, actually, like the data that we saved in the data folder here. So let's import them. Okay. Okay. After importing them, we can see actual the shape of the data, 50 by 50. That's the image size, 50 by 50, then one. So here, like we are creating a sequential model using chars. So we are like adding a convolutional to the layer, then adding the activation layer with the relu and max pooling 2D. Actually, you can search the internet and find what are these. Okay, so this is the actual model. This is the architecture of the model. Okay, so we are like adding dropout layers, like for increasing the accuracy, like like preventing it from overfitting and stuff, right? So then we can, let's run this one and look into a summary of the actual model. You can see the actual model summary here. How many parameters are there, and like something like that. Okay, then actual now we need, like we have imported the data, right? So we need to split into training data and testing data. So we are doing it here. Then we are gonna fit the model. So I have like all the feed, training and testing data have provided here. Then we have the testing and test target, the validation data, and running for 47 epochs, right? So let's run that one. It will take a little bit of time to train this model. So actually the loss should be going down, the accuracy should come up. This is going to take a little bit of time, so I'm going to pause the video here. Alright, now we have finished training the model. So as you can see, we have the validation loss for 0.1, accuracy is 0.9, so that means 90%, 96% accuracy. Alright, after running this script, there will be two plots like this, one for loss, one for accuracy. After the last video, my GPU got burned down, so that means I won't be able to run this further because I'm running on CPU. Sorry for that. So here I have ran this for 5 epochs. For the 5 epochs, the loss have been decreases like this, but the accuracy haven't increased anywhere, because like 5 epochs is not enough. Like you will need to run this like 50 or 100 epochs, right? So when you are running on your machine, make sure run this on GPU and running it for like higher epoch rate, like 50 to 100, right? So after running this, our models will be saved, right? So after showing the graphs, so here we are checking the accuracy. So after running it, I've got to 0.8285 accuracy. That means it's like 82%. So after that, we are saving the model here. Alright, if you're having the same issue as me, because like if you don't have a GPU to run this one, you can use this one, like you can use the Colab to run the script. I have uploaded the script into GitHub Git, so I will provide this link to you. So what you will have to do is press on this one, open in Google, like open in Google Colab. After pressing that one, it will automatically get opened in the Colab, right? So then you, same as the previous, you can run the actual code in here in the Colab. So I have also run this. So I have ran this 40, like 447 epochs. So after doing so, as you can see, we have great accuracy here. So you can use this method also. After that, like you will have like here the data will be automatically saved here. So no, not to worry. Like after saving it, you can use the model. You can download the model and run it locally. Okay, I will run this script real quick. So make sure you are go to runtime and change it into runtime type into GPU. Okay, so it will show it here. Then what you have to do is go to runtime and run all. Press run anyway. Okay. After that, the repository will be cloned here. Will get cloned down here. You can see the files over here, right? So this will automatically process the data and create the data set. If you go here and part 3 into train data, where you have the train data, and the data will be saved over here as soon as this code block is finished running. Okay, it is finished. If you reload this sector, you will see the actual data and target. So after that, the model training will be started. So I am running this for 47 epochs. So let's see. Okay, so as you can see, like this is running quite fast because we are running on GPU. So let's wait. All right, the training is finished, but there was an error. Yeah, it is telling the, because I don't have a models folder, I just created one, so that's why it is giving an error here. So what you have to do is create the model folder here, right? Then on this one, so it will not give you any error, it will automatically save the model. Actually this model is pretty good because it have 0.96, that means 96% accuracy. Also we can see the graphs here, plot, yeah, loss is going down, accuracy going up. So yeah, you can use this method to train your model. After that you can, like the model is saved here, so you can press here and press download. Then the model will get downloaded. Then you can put it into your local machine and run it. All right, now we are in my local machine. So what you have to do is find the models folder in the model creation. Right click on it, reveal in file explorer. Then you need to paste the actual model that we downloaded. So it is 1000, like means 127 MB. So let's change this to model.h5. Okay, cool. After that, what you will have to do is run the main.py, this script. So it will automatically, like it will load the model from the actual location. Then it will give the predictions, and yeah, that's basically it. After this, I will put my demo video. The steps are the same. What you have to do is run the actual simulation, then run this script. So it will automatically load it, load the model, and start running the simulation. Yeah, thank you. This is the script. Here we first of all we need to power up the simulation and then run the program. It will load up the model and the network. Okay, as you see, now the AI is running. Let's see what will happen. As you see, AI is trying to move around and it's doing well. I think I only use like 1500 image for to train the convolution neural network here. So for that type of level of images, this is quite good. Okay, this is the end of the CoppeliaSim Python AI car tutorial series. If you have any questions, please put them down below in the comments. The all the codes are shared in my GitHub account, so they will be listed in the description area also. So thank you. Happy coding. Bye.